Welcome to Interface Studies. My name is Saleh. On general-purpose computers, interaction is effectively standardized. Most software assumes the same pairing: a keyboard for symbolic input and a mouse or trackpad for pointing. Across operating systems and applications, the pattern repeats. You move a pointer, a menu opens, and options appear in a vertical list. This arrangement is so deeply embedded in operating systems, accessibility layers, and interface toolkits that it rarely feels like a choice. It presents itself as neutral, natural, and inevitable. We experience it simply as how computers work. Within this environment, choices are overwhelmingly organized as linear lists. Menus drop down, commands stack vertically, and sidebars and ribbons and panels all rely on the same logic. We scroll, scan, and select in straight lines so frequently that linearity itself fades into the background. On the other side, radial menus, often called pie menus, organize the same choices differently. Instead of stacking options, they distribute them around a central point. Instead of scanning top to bottom, the user selects by direction. These menus are not obscure experiments. They appear in weapon wheels in games, marking menus in professional tools, stylus-based systems, and so on. Many users have encountered them without ever naming them. Like switching weapons in GTA, issuing commands in The Sims, or using marking menus in tools like Maya. What matters is not that radial menus exist, but that they remain marginal in everyday software. Despite decades of evidence that they can outperform linear menus in specific conditions, they are confined to niches: games, creative software, and expert tools. General-purpose desktop and mobile interfaces continue to default to lists. The question then is not whether radial menus work, but why their advantage failed to translate into broader adoption. At first glance, the answer appears simple: trade-offs. A closer look shows something more structural. Early technical constraints shaped interface toolkits. Toolkits shaped habits. Habits hardened into expectations. And over time, those expectations became invisible standards. The dominance of linear menus is not just a story about efficiency. It's a story about how defaults form and how difficult they are to undo. Computer history is full of nuance, but the earliest documented circular, cursor-centered menu appears in the Pixie system in 1969, and later in research at the University of Waterloo explored related radial layouts. In 1986, Mike Gallagher and Don Hopkins jointly arrived at angle-driven context menu. The selection was defined by the angle, and optionally distance, from a central origin, all passed as parameters to a command, with a mouse click triggering an item or submenu. Human-computer interaction research has long examined how people move towards targets on a screen. One of the most influential models is Fitts' law. It describes how movement time increases as targets become smaller or farther away. In practical terms, layout is never neutral. Geometry directly affects speed, accuracy, and effort. Linear menus create a familiar pattern. Items are stacked vertically, so the further an option sits from the cursor, the longer it takes to reach. Each item is also relatively narrow, leaving little tolerance for imprecision. Selecting the wrong item above or below the intended one is a common and well-documented error. Anyone who has scrolled in a long font list in Word or Illustrator has felt this friction accumulate. Radial menus recognize the same choices. Options sit in equal distance from a central point, and selection depends primarily on direction rather than precise position. The interaction becomes a short, directional gesture rather than a careful traversal. But this does not mean radial menus universally faster. Their advantage appears under specific conditions, when the number of options is limited and when the same choices are used repeatedly. Photoshop could not replace its hundreds of commands with a single radial menu without collapsing usability. Controlled studies comparing pie menus and linear menus show consistent results. Radial menus reduce selection time, lower error rates, and improve performance as users gain familiarity. These benefits are real, but conditional. They emerge most clearly in bounded choice environments, not in interfaces designed to explore large command vocabularies at once. One of the most less visible strengths of radial menus lies in how they support learning over time. When users first encounter them, behavior resembles list usage. Users pause, read labels, and make deliberate selections. But with repetition, something changes. Direction begins to carry meaning. An upward movement comes to stand for one action, a diagonal flick for another. The interaction shifts from visual recognition to motor memory. Cognitive load drops because scanning is replaced by recall. Experienced Maya users often trigger commands so quickly that the menu never appears on screen. Only the gesture is performed. A critical detail is that novice and expert behavior share the same physical action. The movement used while reading labels is identical to the movement later executed from memory. Learning happens through repetition, not through switching to an entirely different interaction system. This differs from keyboard shortcuts, where menu use does not teach the shortcut itself. Clicking Save does not reinforce Control S or Command S. A marking menu does. But radial menus do not remove learning curves. They reshape them. They favor environments where repetition is high and where the users are willing to invest in mastery. So why linear menus became the default? Linear menus dominate modern software not because they are always optimal, but because they aligned with the conditions under which graphical interfaces first emerged. Early systems prioritized familiarity. Office software borrowed heavily from paper metaphors, documents, folders, and lists. These forms were recognizable and reassuring, even if they were not always efficient. There were also technical reasons. Early hardware made rectangular layouts easier to render and manage than circular ones. As graphical systems matured, software frameworks, accessibility technologies, documentation practices, and training material all assumed linear menus as the norm. Once toolkits made lists trivial to implement, anything else became custom, fragile, and expensive. Windows menus, Mac menus, and HTML select elements all encode this bias directly into infrastructure. Once these assumptions were embedded, abandoning them became difficult. Linear menus also offer genuine strengths. They scale well to large numbers of commands. They support dense text, searching, and predictable reading order. They integrate cleanly with screen readers and accessibility tooling. The ribbon, as we saw in the previous video, exists because Word and Excel expose hundreds of commands that must remain visible and searchable. Radial menus, by contrast, trade scale and exhaustiveness for speed and motor memory. Their marginal position reflects real constraints, not a simple failure of imagination. And since we talked about games, we have to talk about them in a bit more detail. Video games offer a revealing contrast because they're not bound to a single input device. Consoles rely on controllers with analog sticks, while PC games often use mouse and keyboard. Despite this variation, radial menus appear consistently across both. The reason is not just stylistic preference, it is task structure. Games often demand rapid, repeated selection under time pressure. Attention must remain on the environment, and hesitation has consequences. In these conditions, directional intent matters more than precise targeting. When players must choose quickly from a small, stable set of actions, radial menus dominate. When they are browsing large, changing collections, like inventory, settings, and management screens, lists return. Analog sticks express direction naturally. Mice can approximate the same interaction through quick flicks or short strokes. Having said that, radials fit controllers especially well. While on the mouse and keyboard, they compete with hotkeys, number rows, and scroll wheel cycling. Even so, the same weapon wheel or command radial can survive a change in controller without losing its core logic, because what remains constant is not the device, but the need for fast, spatially anchored, and context-sensitive choice. Now, urgency is not the only context in which this pattern appears. In slower simulation and management games, radial or pie menus often emerge around selected objects. Here, the structure still suits them, a focused set of actions tied to a single target. But stylistic concerns matter more. The circular bloom of options reinforces an object-centric view. Everything you can do to this thing. This maintains a toy-like feel and keeps the inference from collapsing into flat, desktop-style lists. This helps explain why radial menus thrive in games yet remain rare in everyday software. The mouse is not hostile to radial interaction. What differs is the surrounding ecosystem, the scale and variability of available commands, the need for discoverability and documentation, accessibility constraints, entrenched platform conventions, and of course the different nature of every computer user with limited time to develop spatial muscle memory. Where everyday tools must optimize for broad familiarity and dense information, games can afford and often benefit from interfaces that privilege speed, spatial recall, and stylistic fit over strict conformity to standard UI patterns. The story continues with touch interfaces. Their appearance offered a chance to rethink interface geometry completely. Fingers are imprecise. Directional gestures feel natural. Menus can appear directly under the point of contact. Yet, mainstream touch interfaces largely reinforced existing patterns. System settings, for example, still scroll vertically. Many options are included in a very long list. Mobile platforms doubled down on lists, grids, tabs, and long vertical feeds. This was not a lack of imagination necessarily. Touch interfaces prioritized discoverability, clarity, and low learning cost. They needed to support infrequent use, one-handed interaction, broad accessibility. Radial menus survived on touch only in specific contexts: stylus-based systems, creative tools, and games. Where repetition and expertise mattered, radial structure made sense. Where scale and approachability dominated, lists persisted. Touch removed the mouse, but it did not remove the pressure that favors linear structure. In recent years, radial menus have seen renewed attention outside traditional research circles. Projects like PyMenu app on Mac advocates for them not as novelties, but as first-class interface elements. Practitioner discussions highlight their suitability for pen computing, VR, and expert workflows. Designers are no longer asking whether radial menus are better, but where they belong. Linear menus persist because they support scale, visibility, and universality. Radial menus persist because they support speed, memory, and flow. Each encodes different assumptions about how people act and learn. Screen readers depend on linear order. A radial menu has no obvious reading sequence. Emerging platforms such as spatial computing and AI-driven systems reopen questions about interface geometry without necessarily resolving them yet. In environments like Vision Pro or MetaQuest, selection often happens through gaze and pinch, where angular separation matters more than pixel distance. Radial structures may reappear. We've seen that with Tiltbrush, for example, which is a room-scale 3D painting virtual reality app. Linear and radial interfaces embody different models of human behavior. Lists assume scanning, reading, categorizing, and searching. Radial structures assume movement, direction, repetition, and memory. The main point I'm trying to make in this video is that while acknowledging the difference in these interface elements and the fact that neither is inherently superior, interface history does not show a failure to adopt better designs. It shows how early constraints solidify into permanent structures. Once a form becomes infrastructure, it disappears from view and stops being questioned. The point is not to replace lists with circles, but to recover choice where habit has erased it. When designing interfaces, it is worth asking, is this a space for breadth, search, and scale, or for speed, repetition, and flow? The answer will rarely demand a single form, but it should at least make the geometry of our defaults a conscious decision rather than something we inherit.